Okay, so let's take a look at our first dilation here. If you read the directions up top and take a look at the rule that they give us here, we are taking each x comma y, every coordinate, and multiplying times 2, right? 2 times the x, 2 times the y. So if we apply that rule in the first example here, we are going to get, well, 2 times 0, and regardless, is going to actually keep this in the same spot. So a is the same as a prime. In the next example, if I take 1 comma 4 and double or multiply each of the coordinates by 2, we get 2 comma 8. And finally, c at 2 comma 1 doubled will end up at 4 comma 2. Now, if we take a look at our graph and draw our picture, you'll notice that this figure, triangle ABC, got larger and by the scale of 2, right? So in this case, since the scale factor is 2 and it's a number that is more than 1, we're going to have an expansion. All right, so what I want us to get used to is, sure, a dilation changes sizes. However, there's 2 different types of dilations, right? An expansion will make things larger when the scale is greater than 1, right? And there are other examples where we have a contraction. We'll see that in a few minutes. Okay, the next question asks us to find the length of AB using the Pythagorean theorem. So if I go to my diagram here, I notice that from A to B, it is a slope of up 1, right 4. Up 4, right 1. But those are the numbers that I'm going to use in my Pythagorean theorem. So if I just I'm just going to draw myself a little diagram on the side here. Right? So from A to B, it was up 4, right 1, and those are the 2 numbers I'm going to use in my Pythagorean theorem. Now, we're going to leave our answers in exact form here, right? No decimals. And we end up getting, and I'd like you to write this particular way, we get AB is equal to radical 17 units long. All right? Next question, part D. Find the exact length of A prime, B prime. So now this is the image of what we just looked at. So let's go take a look up top. So in order to go from A prime to B prime, here's B prime, here's A prime, it is going to be a move of up 8, right 2. Now, if you think about it, that makes a lot of sense. It was double what we just did from A to B. So now if I come down here, I'm going to use my same idea. So instead of going up 4, right 1, we're going to double that, up 8, right 2. We use our Pythagorean theorem, and we end up getting radical 68. But this is high school, and we know that we should be simplifying our radicals. So 68 is actually divisible by 4, and that is 4 times 17. So what would be the simplified version of A prime, B prime? That's right. It will be 2 radical 17. And that makes a lot of sense because our scale factor was 2, and this is double what AB was, right? Radical 17 doubled. All right, and finally down the bottom here, they ask us about slopes and steepnesses. So hopefully you understand and see or saw what happened in our previous 2 examples with the slope. But let's go up and take a look at BC, slope of BC. Well, here's BC. I have to come down 3, right 1 to get from B to C. So think about that. Slope is rise over run, so that would be down 3, right 1. Now BC turns out to be double that, right? You would move, B prime, C prime. So in order to go from B prime to C prime, you'd actually have to move down 6, right 2. Let's go take a quick look at that, right? Here's B prime, here's C prime. So you would have to come down 6, right 2, which was double what we had from B to C. All right, so regardless, one last thing that we should mention is that if you're finding the slopes of from one side, or the pre-image, to another side, the image, the slopes should be the same steepnesses. And you can see here, they simplified to -3. So each side and its image should be parallel to one another, right? They have equal slopes. Okay, our second dilation here is using the rule 1/2 x, 1/2 y. So similarly to our previous example, we are just going to literally take the scale factor of 1/2 and multiply each of our coordinates by 1/2. Now, what I wanted to make sure you guys are very clear about is if I take 1/2 times x, that's the same as dividing x by 2, right? Multiplying by 1/2 is the same as dividing by 2. So I'm not going to go through each of these, but 1/2 of -10 is -5, and 1/2 of 4 is 2. All right, so we literally divide each of the coordinates by 2, and we get our new diagram over here. If you notice, the scale factor is 1/2. So that is a number that is less than 1, right? It's a fraction, so it's less than 1. It's going to contract our figure, right? So I want you to write this down as well. So it's a dilation of scale 1/2 on triangle DEF, but since the scale is between 0 and 1, think about it, those are small numbers, right? Numbers like this one, 1/2 or 2/3 or 0.6, right? So those would be small scale factors. Those would contract or shrink the figure. All right, next question asks us to find, actually, next two questions ask us to find the lengths of DE and D prime E prime. So let's go take a look. Just like we did in the previous example, D to E is up 10, right 8. D prime to E prime is half of that, up 5, right 4. So I'm just going to duplicate the process like we did on the first example. So your slope is up 10, right 8. So therefore, we're going to plug that into our Pythagorean theorem. Now we get the square root of 164, and that is able to be simplified. So what will be our length of DE? It's going to be 2 radical 41 units. Okay. Now, one more time. Since our scale factor is 1/2, we're gonna go up half of what we did, and we're going to move to the right half of what we did. So one more time, we're going to use that in our Pythagorean theorem. And if you notice, that makes sense, right? Our scale factor was 1/2. So the size of this segment, DE, is now half of what it was. Okay, and our last two questions down here ask us about slopes and the center of dilation. The slope of EF and the slope of E prime F prime. All right, so two other segments. We're going to go up top and take a look. And let's see. EF is up and over. E prime F prime is half of that. So, just like we saw in the previous example, right? The rise and run here was 10 over 2 and 5 over 1. Both of them simplify to 5. Now, one last time for this example, each side and its image should be parallel to one another. They have equal slopes. Okay, lastly, that brings us to the center of dilation, okay? So there's going to be a center point that each of these images are going to either get pushed away from or pulled towards. Now, what do I mean by that? Well, if I look at our diagram here and I draw some guidelines, if you notice this line goes from D back through D prime. I'm going to draw another guideline that goes from F back through F prime. And then I'm going to draw a third guideline from E back through E prime. And if you continue to let those go, you extend those lines, they do come back and meet at the center of dilation, in which case is 0, 0. All righty? Okay, we're going to pick up the speed here a little bit on numbers 3 and 4, but I do want to address the fact that we now have fractions involved. Now, you can use your calculator, which is totally fine, but 3 over 2 is the same as 1.5, and I'm going to use 1.5 here, right? So if I just literally take my scale factor and multiply 1.5 times -5 and 1.5 times -1, it's going to leave me with the new coordinates, -7.5, comma, -1.5. All right, so if we apply that rule, what would be the coordinates for B prime? Well, that's going to be 1.5, comma, 4.5, and if we use that rule again, we get -3, -4.5 for C prime. All right, let me back out, and let's just take a quick look at our picture. So this diagram shows that ABC is now becoming 1.5 times larger, right? Not much, but it's getting, for example, B is getting pushed out from the origin. A is getting pushed out from the origin. So when it's an expansion, when it's getting bigger, the numbers are going to be getting pushed away from the origin, right? Your center of dilation. All right, but let's talk about the notation here for the first time, right? And don't forget, you also have your reference sheets, okay? These are still in your binders, but I'm just going to go down the bottom here and take a look. We're going to basically keep it simple and use these notations and rules. So let's give it a shot. First of all, provide the correct notation. So let's think about this. What letter do we use for dilations? We're going to simply use a capital letter D. There are two bits of information that are important in the subscript. First, we use the scale factor, right? So I'm going to write 3/2. You could even do 1.5. Then I'm also going to write comma, and I want to use or show the center of dilation. So in this case, again, it's 0, 0. And then, of course, pre-image equals image. All right, so it follows the same kind of pattern that the other transformations use, but now we just have different important subscripts. All righty, now the rule for this transformation was to simply multiply the x-coordinate and the y-coordinate by 1.5 or 3/2. So I'm going to start to set up my rule as x comma y maps onto 3/2 times x and 3/2 times y. All right, now just to kind of reiterate something from before, even though this fraction is more than 1. It's 1.5. Any numbers that are larger than 1, any scale factor that's bigger than 1, will be an expansion. All right, what I'd like you to now do is pause the video and check your solutions for number 4. Okay, in our last two examples here, we have compositions of multiple transformations. In number 5, we're going to reflect over the x-axis, and then we're going to dilate by a factor of 5/4. So I want to just kind of have you guys just provide some answers and just check your work. So in the first example here, we're supposed to draw triangle ABC, which you see here in blue. What we're supposed to do first is to reflect over the x-axis to form triangle A prime B prime. So what rule would we use to reflect over the x-axis? All right, so we are going to take the opposite of the y and leave x alone. So what would be the coordinates of A? Well, let's think about that. The opposite of 0 is 0 anyway. And then B prime will end up where? And then finally, taking the opposite of 0 once again is 0. All right, so now that effect will look like this on the graph, right? Your blue triangle ABC will reflect down over the x-axis and become A prime, B prime, C prime. Okay, second transformation is to next dilate by a factor of 5/4. So what rule will we use from A prime to A double prime, B prime to B double prime? So we're going to multiply each of the coordinates by 5/4. All right, so A double prime, that's easy. Zeros times 5/4 is going to stay 0. What will be the new coordinates of B double prime? All right, so now we're multiplying by 5/4, and yeah, you could use your calculator, but we get negative 2.5, comma 5, and finally negative 6.25, comma 0. All right, now think about that. What's that going to do? Well, 5/4 is slightly bigger than 1, right? 5/4, if you think about it, is 1.25. So it's getting 25% bigger. What will that look like? It'll look like this red triangle right here, just slightly larger, okay? All right, now it says write the rule that describes the transformation that maps ABC onto the double prime. So that's what we're doing. We're going from start to finish. So it's almost like we are mixing together these two rules. So for example, our first step was to take the opposite of y, and then our second step was to multiply both coordinates by 5/4. So what do you think the rule would be to map ABC onto the double primes? Well, like I said, we're basically putting the two rules together. We didn't do anything to x after the first change. We didn't do anything, we took the opposite of y for the second change. So you'll see that negative out in front. What else did we do? We multiplied by 5/4 in each case. All right. Lastly, the notation's a little tricky for this because it's the composition of two transformations. So what I'm going to start off by saying to you is, what was the first transformation and what letter do we use for it? Well, the first transformation was a reflection over the x-axis, so we're going to use the lowercase r. All right, so I'm going to start off with the reflection over the x-axis. Now, I'm also going to add pre-image and image, okay? But if you remember, we have a second one, and if you want to, you can use parentheses. I know, remember, we use like nested parentheses, but I'm going to use that little open circle thing, right? So I'm going to put my little circle, and then we're also going to now do this second, right? So just like we've seen in the past, that would be your first transformation. This would be your second. Okay. All right, let's finish this up. So down below, we're supposed to do two things. Rotate 90, dilate by 1/2. Okay? So what I'd like you to do is tell me some of your coordinates here, right? So if we're going to rotate 90, first of all, what rule do we use? So we're going to do opposite y comma x. So where would point P end up? All right, there we go. We're going to end up at -8, -8. And there's your Q and R as well, so you can check those. And then what's that going to do? It's going to rotate our triangle 90 degrees. And since it's positive, which way is that? Right, that's going to be counterclockwise. All right, and our last change, or our second change, is going to be to dilate the new figure by a scale of 1/2. So what would be the rule that we use to go from P prime to P double prime? That'll be 1/2 x, 1/2 y. All right, and here are your new locations. What will that look like on the graph? Well, let's think. Here's triangle P prime, Q prime, R prime. It's going to get shrunk, or the word would be what? It'll be a contraction, and it's going to pull it towards the center of dilation, which is 0, 0. Okay? All right, there you go. There's your little triangle. And our last question asks us, what rule can be used, again, look at this, to go from start to the double primes? So basically skipping from start to finish, okay? We're going to have to put these rules together. So what do you think would be a rule that maps PQR onto the double primes? All right, so good. Notice the Y was moved up front, and it was opposite Y, so that's why you'll see the negative there. Okay, and then finally we multiplied by halves. All right, everybody. So I hope this helps. I hope you were able to check all of your homework and just come back to this rules sheet, to this homework in case you have any troubles with some dilations. Thank you.